Hi there. In this video, I'm just going to talk about magnetic field. What is a magnetic field? And there are so many terms we have to learn. So I'm going to teach you all of these things. And simply, you have already know what is a magnet. You may have already touched a magnet and attached many iron nails and other things around a magnet. So basically, there are two types of basic magnets: the electromagnets and permanent magnets. Firstly, I'm just about to teach about permanent magnets. A permanent magnet has two poles, and even the so does the electromagnets as well. So in this case, the magnets can attract these type of certain material like iron nails and any type of magnetic material. What are the magnetic materials? There are basic magnetic materials. There as a paper clip, an iron nail, the spoon, and the non-magnetic materials like plastic and the copper coin. Even not all the metals are magnetic, like aluminium and copper are not extremely magnetic, and cobalt, nickel, and just steel are supposed to be very good magnetic materials. Now you can just detect the magnetic field using a certain compass, because when you move a magnet close to the compass, then the needle of the compass begins to move here and there. Okay, now so you can, in the same way, you can trace the magnetic field using a compass. I'm just going to discuss you this one later, and you can just trace the magnetic field even using this simple technique. Okay, let's move to the other part. Okay, now this two things can be happens when you place magnets in these three orientations: south to south orientation, north to north orientation, and the north to south orientation. Let's see what should happen to there. So when the magnets are just kept like this, then both the magnets are going to pull apart from each other because of the strong repulsion force created by these three like terms. And in the same way, north and north repel away each other, so it is like parallelly happening again. So the magnets are just repelled away from each other. That's a repulsion force. But when you keep the magnets north and south close to each other, they are going to attract to each other and just combine like in this way. This is a very simple thing you may know this from CNC or grade 3 4 like that as well. Okay, next part. So the magnetic field, how does the magnetic field change? Let's see. So the magnetic field can create it around the basic magnet, like a bar magnet like this, always running away from the north pole and reach to the south pole. And the tracing magnetic field can be done using a certain simple compass. Then the compass will just direct, the compass needle direct the magnetic field along the path, and you can just draw the magnetic field along that. The simple representation here. And the 2D magnetic field lines, you can just imagine, and not with the direction, just the shape of it, just using iron failings over the magnet. And better to keep a certain opposite around up just above the magnet and see the pattern. Then magnet and the iron filings can be easily detached from each other. Then the next part is the magnet to trace it. The 3D model. 3D model can easily be detected using a certain magnet put in a certain glass test tube, and so the magnet is in the test tube. Then you have to dip it in glycerin or oil, certain transparent oil, then put some magnetic iron filings around it. Then the iron filings just going to deposit around like in this way, making a certain 3D shape. It's really simple. And okay, and why are we just attaching certain test tube in it? Because the test tube can just get the magnet and the iron filings just get not too attached to each other, just separate from each other, like the iron FOC just applied in the 2D model as well. Now the next part. Okay, the magnetic fields can be like in different shapes, like north to north, so one magnetic field like in this way, and a certain U-shaped magnet, U magnets in this metal, and two different magnets when one magnet north south pole of the other magnet to attract to the north pole. So it's like this way. So these are really simple things. Apart from that, there's something called right hand grip rule. You can find out the direction of a magnetic field around a current carrying conductor. So you have to just roll your other fingers in the right hand like in this way, and keep the thumbs up, and the thumb indicate the direction of the current, and the rest of the fingers when direction indicates the direction of the magnetic field. In this one, the lines are attached in the anti-clockwise direction. Really simple to understand. And so let's find out, so what is the relationship of a magnetic field in a certain two magnets, bar magnets. Then it's going to mostly like a certain parallel magnetic field and a very strong one, and the outside of the region there will be something like this curved one, but between the magnets it's going to be a very perfect parallel line, right? Perfect line of parallel. Okay, now the parallel lines are here, and in the same way, just for the so current carrying conductor, it's creating certain circular loops around it. So according to the Fleming's like of right hand grip rule, in the right hand grip rule it's kind of anti-clockwise. So when the two fields like of the magnetic field created by the current carrying conductor and the parallel lines, is going to create something like in the magnetic field due to the permanent magnet is a parallel line, and direction of the current in the page, so the field due to current carrying conductor is going to be circular one. So these two interact with each other and distort the forces, like field lines are getting concentrated and top, and the bottom is going to be dispersed. So as a result of it, there will be a magnetic push downward. So that is how it creates a certain force in the current carrying conductor in a magnetic field. Really simple. Now we have to perform and just find out how does it affect. So we have a certain rule called Fleming's left hand rule. Fleming's left hand rule is nothing when you just spread your all three fingers in left hand. The thumb indicates the direction of the magnetic field, and the force, and the index finger indicates the direction of the magnetic field, and the middle finger indicates the direction of the current. So you can easily remember it in using this method. FBI. What is FBI? Federal Bureau of Investigation. Like no, it's different thing. So FVI method. So F is for the force, B for the magnetic field, and I for the current. So have a good look at this diagram. Very simple diagram. There are just two magnets, and the one magnet is the north pole and the other part of the south pole. Then there's a certain parallel magnetic field, and there is a current carrying conductor which brings current into the page. This is the 3D model, so that's why the slanted and slanted ones are like so into the plane. So when it's into the plane, just spread your hand and see. This is the representation. So the index middle finger indicates the direction of the current, so the index finger, and the current indicates by the middle finger over here, and automatically the left hand's thumb indicates downwards, placing downwards. That means the force is downward. This is going to get dragged downward like in this way. So the field is going to drag it downwards. That is how the force affecting in there. So the next part, let's see how does it happen. It's from the north pole, and it's from always in lines from the north to south, and the current source, that the current is just coming from the right hand side to the left hand side in the model. That means mostly outside of the plane, because this is 3D model. So the motion or the other one is known as the force is just upward according to the Fleming's left hand rule. This is all about basics of the magnetic field. In my next video, I'm just going to talk about the Mott effect and another one called the loudspeaker mechanism. And my very next video going to be electromagnetic induction. Let's stay tuned and subscribe to my channel and hit the bell icon to get further notifications. Okay, God bless you.